I feel like it. All right, here we go. All right, so what we've done so far, we've done graph analysis. Hey. Zip it. Yeah, they can hear it. All right. So, here's what we've done so far. We've done graph analysis. We did the X. Boys, I'm serious. Stop talking. Like, is that clear? We've done graph analysis. We did the X and the Y intercepts. We talked about increasing and decreasing intervals, positive and negative intervals. We talked about maxes and mins. And then we talked about end behavior of the graph, and that was the limits. So today what we're going to do is just talk about parent functions. So the first parent function, which we've done forever, is linear, which is y equals x. So if I made a t-chart to graph the line, if I made x -2, what would my y value be? Right. And -1 would be -1. So when I graph it, it makes a line. Bless you. And this is what your handy-dandy ID is good for. It draws a perfect straight line. And the domain is -infinity to infinity, and the range is -infinity to infinity. And what kind of symmetry does that line have? X, Y, or origin? Origin, because if I turned it upside down, it would be the same graph, so it would be an origin. So absolute value looks like this. We had the little absolute value symbols. And if I put the absolute value of 4, what is the absolute value of 4? 4. And the absolute value of -4 is 4. So if I make a t-chart of that, if I put a -2 in there, the y value is 2. If I put a -1 in there, it's 1. So this is what this looks like. It's symmetric around which axis? The y-axis, which means I can fold it in half over the y-axis. Also, where's the vertex? 0, 0. So the domain of this is -infinity to infinity, and the range, which is bottom to top, would be 0 to infinity. So the next one is the quadratic, which is y equals x squared. So if I put -2 in for x squared, I get +4. If I get -1 in for x squared, I get 1. So when I graph, and this is also symmetric around the y-axis. The vertex is at 0, 0. The domain is -infinity to infinity, and 0 to infinity for the range. But what's the difference between the quadratic and the absolute value that I just did? It's what? Say that again? Right, but what's this? But are these y values also positive? So what's the difference between the two? So, but what about the absolute value? One is a v and one is a u. So the absolute value connects two straight lines, the two parts of straight lines, and the quadratic is the first time you get curves. Okay? So let's go on. I want to go across and do the square root function next. So the square root function is the inverse of the parabola. And so what that means is the square root function is a parabola that is going to lay down. So when the parabola lays down this way, but what do I know about a square root? Can I take the square root of a negative number? No. So if I make my t-chart, if I type in a -1 in the calculator, it says error, right? So we can't have any negatives. So I'm going to start at 0, and I get a 0. If I put a 1, what's the square root of 1? 1. What's the next x that we're going to choose that's a perfect square? 4, and the square root of that is 2. So this is the quadratic, and it's laying down, but it's only the top part because we can't take the square root of a negative number. So it's a restricted domain. And so the domain is going to be 0 to infinity, and the range is 0 to infinity. So the cubic is x to the third. So if I made a t-chart, so -2 to the third power is -8. And -1 to the third power is 0, 1, and 8. So when you graph that, -2, -8, so the domain is -infinity to infinity and -infinity to infinity. So if the cube root is the inverse of a cube, what's going to happen to the function? It's going to have to switch, right? It's going to have to lay down. So this one looks like this. It's the cube root of x. Thanks. Okay. So what would the cube root of -8 be? -2, right? And the cube root of -1? -1. Going on to number 7 is the rational function. And that's 1 over x. So if I look at 1 over x, y'all, what number can x not equal? Why? Because what happens if you put 1 over 0? It's undefined, right? So at 0, we're going to put asymptotes here. So at x equals 0 and y equals 0, those are asymptotes. So now, I always kind of explain this to my classes. You can't divide by 0, right? It's like it blows the line up. So if it blows the line up, this is what it's going to end up looking like. If I put 1 in for x, 1 divided by 1 is 1. What if I put a half in for x? So if I put a half in for x, I get 1 over a half. And what does that equal? If I put a half in for x, what do I do with the fraction? There's not a single person. Do the reciprocal. So if I do the reciprocal, it becomes 2. So at a half, it's 2. So it's getting bigger. What if I put 2 in for x? What does y equal? A half. So the rest is getting smaller. So I get a branch like this. It's like it's a line, and at 0, 0, it has to blow in half. Like it can't touch the zeros. And so if it's that way, if I put a negative 1 in for x, what's the y value? Negative 1, right? And so it's going to go this way. So my domain is all real numbers except what number? And the range is all real numbers except what number? So we have all real numbers except 0 and all real numbers except 0. The inverse squared looks like this, 1 over x squared. So just like before, where am I going to get asymptotes? Zeros, right? I still can't have 0 in the denominator. If I put 1 in for x, what do I get? 1 divided by 1 is 1. So it's still 1. So this branch didn't change at all. But what happens this time if I put negative 1 in for x? It's still 1, right? So my negative 1 would be 1. So this time, so what did it do with this little branch right here to become 1 over x squared? It took this and just flipped it up. Okay? It just took it and it flipped it up. So we don't have any what? We don't have any negatives. So the domain here is going to, for all reals except can't equal 0. And what's the y value is going to be? 0 to infinity, right? Okay. On the exponential, Okay, so when we do the exponential is a number here, and it can be 2 to the x, 3 to the x, 10 to the x, it doesn't matter. I'm just going to use 2. Because then for the log, we're also going to use 2. And the reason I'm going to do that is because the log and the exponential are inverses of each other. So if we make a table for the exponential, first of all, what's 2 to the 0 power? 1. Anything to the 0 power is always 1. So 2 to the 0 is 1. If I put 1 in for x, what is your y value? 2. If I put 2 in for x, what is your y value? 4. If I put negative 1 in, what is your y value? 1/2. Okay, I don't get it. It's not a question, first of all. And second of all, negative 1, what does a negative exponent do? What does a negative exponent do? It has to go to the bottom and become positive. So this moves this number to the bottom and it becomes positive. So you get 1 over 2. 2 to the negative 2 would be what? 1/4. It would move it to the bottom and become positive. So when you graph that, you have 0, 1, which is right here. What? Say that again? You move it to the bottom of the fraction. So look, when I move this down, so I move this to the bottom and it's 2 to the first power, right? When I move this to the bottom, it's 2 to the second power, which is 4. So this is what the exponential looks like. And it does have an asymptote at 0. So the domain is negative infinity to infinity. And the range is bottom to top, so that's 0 to infinity. Now, we wrote this, the f of x, what's that the same as the letter? The f of x is what? So this is y equals 2 to the x, right? So here, I would have y equals the log base 2 of x. So if I wanted to write this in exponential form, do y'all remember the little circle thing from last year? So this would be 2 to the y, and it would equal x. 2 to the y equals x. Yes. So look, the 2 to the x and 2 to the y, that's the inverse. They're inverses. So once you have a table for your exponential, all you have to do is flip the x and y, and you can graph your logarithm. So I'm going to flip my x's and y's. I put a dot there and it shouldn't be. Okay, so if y equals 0 was an asymptote for the exponential, then x equals 0 is an asymptote here, because they're inverses. If the domain for the exponential was negative infinity to infinity, what does that become for the exponential? But is it domain or range? It's domain for the exponential, so it's range. You have to flip them. The x becomes y, and the y becomes x. So the y becomes negative infinity to infinity.